Well, in this audience, do you have anyone who have joined? Not one, maybe three. Who have joined new.
Yes, sir.
Indrila Chatterjee. Indrila, are you new?
Indrila Chatterjee, sir. I've
Yeah,
joined.
are you new? Are you newly admitted?
Yes, sir.
Okay. So you're from which college?
Sir, Vidyasagar College.
Pardon?
Vidyasagar College.
Vidyasagar College. Okay. How many are you number? Do you have
Sir, I really
newly
don't know the actual
admitted?
count, but approximately 10 to 12.
Do you have their contacts, email IDs?
Yes, sir. They're all in the group, I guess.
No. I have got only three, so I have shared only three. Officially, I have got three only.
Sir, others are in the college group that was organized by the CR. So everyone, I think everyone has got the email about your meeting
My
for the
email
class.
they have got. Are you sure?
Yeah. Sir, I will contact the CR once then and let you know.
Immediately, you just call someone and can get it verified.
Yeah, yes, sir. Yes, sir.
Only Oindrila is the new one in this group, right? So far, those who have joined, or
Yes,
is it
sir.
so? Is there anyone apart from Andrila? Is there anyone apart from Oindrila? No? Okay. So how did you spend your holidays? Are you all safe and all vaccinated? Are you all vaccinated? Are you all vaccinated? Fully means double dose already done. Most of them. Okay. So what's the news about your opening the university? Do you have any idea? Your voice is very, very feeble. Okay, anyway, I'm raising it. Yeah. So you are the first semester in radio physics. It is your third semester, means the first year in radio physics. So that's why your chance is least. I have no idea, but the practical classes should be started soon. But all depends on the policy and final decision. I have no idea. Shayanadip,
Yes, sir.
ঐন্দ্রিলা যা বলছিল, আর ইউ শিওর যে সবাই আসবে, বাকিরা সবাই জেনেছে?
হ্যাঁ হ্যাঁ স্যার, মানে আমার যে কমন মেলটা আছে ওটায় সবাইকে অ্যাড করা আছে, এবারে আপনি মেল করলে ওটা সবাই পেয়ে গেছে।
আচ্ছা, ওই কমন মেইলে অ্যাড করা আছে, ফলে ওটা আমার কাছে না এলেও চলবে। ওকে, দেন ইট ইজ ফাইন। Actually, I'll have to leave for university. So I maybe for 1 hour or more, little bit more. So you give me signal whether all are present or not.
Okay, sir.
What is the total count right now?
Sir, at present it's 19, but I think around 30 should join.
They're supposed to, yeah. Okay, so you let them know, all of you should be very careful about your timing. Are you getting some noise? Are you getting some noise?
No, sir.
নয়েজটা
No, sir.
খুব অসুবিধা করছে কি?
না স্যার
একটা
না
একটা
স্যার,
একটা
ঠিক
একটা
আছে।
একটা একটা ছেনি হাতুড়ির শব্দ হচ্ছে আমার বাড়ির খুব কাছে। খুব অসুবিধা হচ্ছে না তো? ওকে
sir.
ওকে
না স্যার।
ওকে। Shanadip, you give me the count.
Sir, it's 20. I think more should join.
Okay, so let me wait for a couple of minutes. Two things I remind you again. If you are serious enough, you should not use mobile phone for your classes. You should use either desktop or laptop computer. You should not use double devices together, that will create some noise. You should use only one device at a time. Okay. So I'm really starting the content of our curriculum, otherwise we'll be late. Are you using your separate exercise book? Separate exercise book and pen. Are you keeping this note using pen and paper?
Yes, sir.
Yes, sir.
I recommend everyone should use it with you. Otherwise, you are going to lose. If you don't care, I have no point, but it is my duty to keep you alert always. I am trying to share. Is it visible to you?
Yes, sir.
Yes, sir.
Okay. We are coming directly to the specific topic for this paper, for this curriculum. And in short, we'll call it transmission line. So this is the first module of transmission line. Sometimes there is some issue with this. Let me clarify which one is transmission line. So I need to move this one. Can you see the screen?
No, sir.
No, sir.
No, sir.
Okay, just wait. There is some issues. some issues. I'm trying to solve it. Okay. This one sharing issues. I'm trying to solve it. Are you going to get it?
Yes, sir.
Yes, sir.
Okay. Well, what do you see? What do you see?
The two girls with a bicycle.
Two girls on a bicycle. Are you familiar with bicycle? Do you ride bicycle?
Yes, sir.
Good. But I'm sure all of you cannot. Those who are in Kolkata, they definitely, most of them, they don't know how to ride. Well, this ground, bicycle and two girls. You probably can see this one, second picture.
Yes, sir.
Yes, sir.
Third picture.
Yes, sir.
Fourth picture. Can you guess? I'm trying to see something. What's that?
Transportation.
Transportation. No. Give a second try.
Increase in the number of person. There was 2 person. Then there was a tricycle.
Good point, because it is logical. But no, I really don't mean that one. Third try.
How change the world? Transportation.
Third try.
The place that it is traveling, like in a bicycle it can be in a, like the plane is a grass, whereas it is for a tricycle it's a road, like a mud road. For
Absolutely
cars
correct.
it's
Absolutely correct. You want a good name? I cannot see your name. That's why I'm asking. Oh, Oindrila.
Oindrila. Yes, sir.
Oindrila. Okay. Oindrila from Bidyasagar, right?
Yes, sir.
Yes. Can you see your some friends in the group? I cannot see right now. Can you see some of your friends who have joined? New friends?
Yes.
Okay. I'll talk to them later. Actually, oh my God. Okay. Actually, that is true. That is the aeroplane. You cannot take aeroplane to bus route. In this road condition, the aeroplane cannot move. In this road condition, bus is okay. Cycle rickshaw is okay. But you take the bus on the same road of cycle rickshaw, bus cannot move. You take the flight or bus on grass, that is the paddy land. This is not a smooth one to move. So that means, depending on your communication means, you can choose the road. Each one is vehicle. Cycle is okay. Cycle rickshaw is okay. Bus and car, it is our common vehicle. and aeroplane. But depending on their sophistication, depending on their requirements, you need to prepare the path or the road or the communication ground. So with this information, let's come to here our transmission medium. The earlier one was also transmission, but it is not transmission, it is the communication, the physical communication from one place to another place. And here also we are considering transmission. Transmission of what? Transmission of what? Anyone?
Energy.
Better to say electrical signal. Because you are communication engineers and you are dealing with electrical signal. It is signal, but the nature of the signal is electrical. So the signal or electrical signal, when it is to be transmitted from one point to another point, you need mediums or media. Multiple media you need. In British English, it is media, but Americans, they have made things very, very simpler, though it is not a good English. So sometimes we use it media. Like an antenna. Antenna plural is antennae. But nowadays, the whole world has accepted antennas. Since Americans use antennas. ইয়েটা প্রবলেম করছে এই আমার লাইটটা প্রবলেম করছে কেন করছে আমি জানি না আটকে যাচ্ছে anyway I need to again unshare. You're sharing Microsoft PowerPoint. It is not going on. Why not? I cannot understand. What happened? I cannot get it. Just a minute. Let me check again. Oh, again there are two. Why it is so? Yes. So like cycle, like rickshaw, like bus or aeroplane, you need to find out the matching of transmission medium and the nature of the wave or nature of the signal. And do you know what do you call this signal? It is electrical signal, right? It is correct. It is electrical signal.
sir.
But if you tell more precisely, like a very sophisticated engineer, then it should be little bit different. You should call it time harmonic signal. Do you follow my point? Time harmonic
sir.
signal. That means it is varying with time. It is called time harmonic signal. So the time harmonic signal, it is always in the form of wave. It is time varying signal or time harmonic signal. This is the, probably you are being exposed to these names in a series. So be very careful to learn about these divisions of frequencies and waves. I'm going to help you. This is called VHF. So on your paper, you should write VHF, and VHF frequency is okay. For you, it will be easier. I'm coming to this frequency part later on. Time harmonic signal was first used for communication in the form of wireless, and that was in 1887. The first time harmonic signal for communication, it was accidentally or somehow it was chosen or it fell within the band of VHF. VHF is very high frequency. Before that, before 1887, such high frequency signal was not in our knowledge. So the electrical engineers, they got the taste of high frequency signal, so-called high frequency. It is precisely you call is very high frequency, but all these are high frequency signals in 1887, because before that only one harmonic or time harmonic signal was known commonly. That is the three-phase generated power. In US it was 60 cycles per second. You know it probably, 60 hertz. And the British standard, it is 10 count less, that means 50. Are you aware of the frequency of your house connection or house signal, electrical power? The supply of electrical power, it is with which frequency?
60 hertz.
Sir, 240.
230 volt. But what is the frequency? What is the frequency? That is, what is time harmonic frequency of the signal?
50 hertz.
60 hertz.
50 hertz. In US it is 60 hertz. So before that, electrical engineers were concerned about only 50 hertz and 60 hertz. So first, compared to 50 and 60 hertz, a very high frequency signal was generated. It was in 1887 by Heinrich Hertz, who is the father of radio wave engineering or radio engineering. And immediately after that, exactly not immediately, but anyway, it is immediately after that, two different frequencies were explored. One is medium wave, another is SHF. It is called super high frequency. In 1895, that means the scientists or radio engineers, they explored two different frequencies for their purposes. In 1895, a high frequency or microwave was generated in the city of Kolkata by Jagadish Chandra Bose, you know, and its contemporary development of medium wave frequency or medium frequency signal for transatlantic experiment in 1901, but he started his experiment in 1894, 1895. That's why I have kept both the years identical so that it is not misleading to you that who came first. So one is Marconi, and Marconi was in Italy. So in his own way, he developed a system, but it is a very giant system for very long distance communication in medium wave and short distance communication in similar time using much shorter wavelength. Although the demonstration was contemporary in 1894, 95, the same also happened in case of Marconi, because Marconi started his experiment a bit early, but transatlantic experiment was done in 1901 December. So you should start from here because it is very important band. You should write it microwave. So microwave starts from 3 gigahertz and ends at 30 gigahertz. Once you write it, you have the option to go up and go down in terms of frequency. That's why better we take the reference microwave frequency 3 gigahertz to 30 gigahertz. Just below, better we come down, just below it is called UHF. Very useful communication frequency. It is from 300 megahertz to 3 gigahertz. 300 megahertz to 3 gigahertz. Everything is a multiplier factor of 3, you see. Below UHF, it is VHF, very high frequency, 30 meg to 300. Just below that, it is high frequency, 3 megahertz to 30 megahertz. Below high frequency, medium wave frequency, 300 kilohertz to 3 megahertz. And below medium wave, it is called low frequency, LF. Low frequency, 30 kilohertz to 300 kilohertz. Below low frequency, you should note it is called VLA, very low frequency. So you can guess that very low frequency covers our audio range. Do you get my point? আমি কারোর মুখ দেখতে পাচ্ছি
Yes,
না, so
sir.
it is very difficult to follow whether you are interested or not, or whether you are going through or not. At least someone should just respond that whether you are getting me or not. Do you have any question? Do you
No,
have
sir.
any question? Yes,
No,
please.
sir.
No,
No.
no, sir.
Then I have a question for you. So can you give examples of usage of each of these bands? At least one or couple of examples for each band. So better we start from microwave frequency application based on your common sense or information or knowledge. You are quite informed nowadays, so I know you know microwave frequency.
Gun diode.
Sir, is the mobile phones.
কি নাম বললে? Your
Gun
name?
diode. Subham Kumar Gupta.
Yes. When you are going to Google search, this all these nonsense names will come very soon. I guess it.
Microwave oven.
No, no. Don't do Google and jump into that. All stray words. If you know, you tell. If you don't, say no, sir. We don't know. You know? Do you know or not?
Sir, mobile
I-
phones.
Sir, cooking food.
No, not mobile phone. Okay. Who are you? What's the name?
Sir, Shayan Nodi.
Hmm? Mobile?
Shayan Nodi.
Shayan, no, mobile. Okay. Shanadip, you go to Google and now write the mobile phone frequency or cell phone frequency. You tell me what frequency you are talking about, and you will see. It is you will be in the domain of UHF. You see.
Yes, sir.
What is the frequency? You tell for your friends.
Sir, 900 megahertz to 1800 megahertz.
Aye, 900 to 1800. So it falls in UHF,
Yes, sir.
right? So you
Yes, sir.
get the first answer or example that UHF band you are always using, but you unknowingly you don't know it is UHF. Okay, there are plenty of applications in UHF. So we come to microwave. One very simple.
So microwave
Yeah.
ovens, microwave oven,
Oh, patties,
mic.
no? Patties.
No,
Huh?
sir.
Patties, shingara, আর কি কি আছে?
No, sir.
Fine. Microwave oven. So are you using phone with you? Do you know precisely what frequency is for microwave oven? There is a particular frequency. You should know. You are right, it is microwave oven. But I am asking about communication purpose. Anyway, microwave is one application. I want to know the exact frequency. Search by Google.
The 2450 megahertz.
2.45.
2.45.
Right.
Yes, sir.
And the device is used, it is called magnetron. Magnetron is the tube and magnetron is the source. It is exactly 2.45 gigahertz. So now, according to this division, 2.45 does not fall in microwave domain. তাহলে এটাকে
Yes,
মাইক্রোওয়েভ
sir.
বলি কেন
Yes,
আমরা?
sir.
তাহলে মাইক্রোওয়েভ বলি কেন? That is one big question. So microwave border is bit hazy. So once you get it that it is from 3 to 330, তারপরে যখন একটু পাকাপোক্ত হবে তখন তুমি দেখতে পাবে it is not really 3, it may be sometimes 1 gigahertz. Okay. So
Okay, sir.
if you are interested, you can note it from me. Write down. In a separate place, you write only microwave bands. Only microwave bands. Starting from 1 gigahertz. 1 to 2, 2 to 4, 4 to 8, 8 to 12, 12 to 18, 18 to 26, 26 to 40. Interestingly, this technology was primarily developed in Great Britain or in England. So most of the standards are under their control, and they made these bands like this. And from its inception, we have been following this nomenclature, their dimensions. Lot of things will come later on, you'll see. It depends on which country was the leader, and according to them, their choice, they did this standardization. Now, can you help 1, 2, 2, 2, 2, 3 এই ব্যান্ডগুলোর নামগুলো তোমরা গুগল দেখে কেউ বার করতে পারবে? You try it out. You search microwave bands, then you will see what's that. What's that? L S, go through. LSCX. 1 to 2 is L, 2 to 4 is S,
CXKUK.
then it is called KU, then K, then K. 2K K. If you ask me that what's the basis of these names, we don't know. Definitely there is some clue, but I don't know. So LSC, X, KU, K, and K. So there is no very sharp division. Sometimes we go up to 40 gigahertz. Sometimes we come down to 1 gigahertz. So in between 1 to 40, these are our microwave bands. So sometimes we take a part to UHF, and sometimes we take a part to microwave. It all depends. Just above microwave, we call it millimeter wave. Just above microwave, we call it millimeter wave. It starts from 30 gigahertz and ends at 300 gigahertz. Why it is called millimeter wave? Because from the frequency, if you convert the wavelength for millimeter wave, then you can find this particular domain. For this particular domain, the wavelength of the signal varies in between, you determine, varies in between which two figures? You do calculate it. Speed of light divided by 300 gigahertz, speed of light divided by 30 gigahertz. You do and tell. Huh? 10 mm to 1 mm, absolutely correct. That's why it is called millimetric wave or millimeter wave. So, for microwave, you do the similar business and you can find, or you can do the similar exercise, you can find. You do the same, 3 gigahertz and 30 gigahertz for microwave. Exactly. That's why it is called centimetric wave. 10 centimeter to 1 centimeter. It is called centimetric wave. So one is millimetric wave, another is centimetric wave. Now again we come back to microwave because you only told about its microwave heating application, that is microwave oven. But for communication, very common example is the satellite signal. That is when you are communicating with the satellite, either through uplink or through downlink, maybe for your home television or maybe by BSNL for commercial services, whatever it be. All these occur in this band that is microwave. Another example is radar. Radar for defense, for air surveillance, for security, for navigation, for aviation, whatever it be. Most of the radar services, they are operating in this band, that is microwave. Now we come down to UHF. You got one example. Well, you should be connected. Actually, this connection will be over within next 5 minutes. So I will send another link soon. And you should join immediately.
Okay, sir.
And so one example you got, right? UHF, that is mobile phone.
Yes, sir.
Yes, sir.
Another popular
sir.
one, another popular one. Right. What are the bands of radio and television? Do you have any idea which are on air? No, sir. Okay. What's the common term of the FM channels?
Sir, 98.3,
98.3. Actually,
95.8.
98.3 is megahertz. So now you look at here the which band
Yes,
it
sir.
is. 98.3. It is in VHF. 98.3 is in VHF, right?
Yes, sir.
Yes.
Yes, sir.
Most of the FM channels 88 to 108. It is typical band. 88 to 108 megahertz. So it is in VHF. But in UHF also there are several television channels on air. Television on air or through cable, they are using UHF bands, lots of UHF bands. So both VHF and UHF are very popular bands for wireless communication by defense, by police, by coast guards, by forest department, by railway. That is their dedicated services, not for public use. It is their dedicated services for maintenance, for signaling, many other services. In forest, it is the forest security communication. So for these two, VHF and UHF, these two bands are very special and popular. And police, particularly police and police wireless. Sometimes you can see the police are talking over wireless and they are using either VHF or UHF band. If the device is very tiny, then it is sure that they are using some UHF band. And if the set is bit bulky, then it is VHF because it is in the lower frequency, that is larger wavelength. Any example for high frequency application? It is difficult for you because it is for radio shortwave communication, mostly radio shortwave communication or some dedicated purposes for defense. Radio shortwave and some dedicated purposes for Navy, for defense, for maritime. Maritime means ship to ship communication. Suppose when there was no such mobile or satellite services, before satellite services came in operation, HF was the main technology, that is high frequency was the main technology by wireless to cover the longest distance. It used to use, although not satellite, but satellite-like communication by reflection through ionosphere. Satellite is far away from, it is, you know, the distance from our Earth's surface. But Anudeep, what about your count?
So it was 28.
20, yeah, I'm seeing now 20. What was actually your count earlier?
Sir, it was 28.
28, okay. I doubt that this class will be offline, particularly my class, I have doubt. Twenty, 25, 25. So we can expect three more, right?
Yes, sir.
Yeah. Maybe they're facing some problem. I think it is budget 27 including me. Right.
Yes, sir.
Yeah. So should I wait or?
Sir, I think we should start. Sir, I think you should start.
Yeah, if there is anyone, so give me one reminder because I may not get this indication because my screen will be
Okay,
blocked.
sir.
My screen will be blocked.
Okay, sir.
Okay, so I'm going to share. Hopefully you can see it, right?
Yes, sir.
Yeah.
Yes, sir.
So high frequency, I just mentioned. Do you have any idea about medium wave application? Unfortunately, your answer will be no. But during our childhood, this frequency was the only source of amusement because it is our radio, our AM radio, amplitude modulated radio. The radio wave communication is especially for radio wave communication, and it is based on different mode of communication. Hopefully everything will be taught in this curriculum. This curriculum? No, not this year. Maybe next in the next semester. Well, so I'm coming to this part. I already have discussed this, so you can have a note. Which part is millimeter, which is microwave. I'm not much interested in terahertz right now because in terms of communication, in terms of radio wave application, it is very difficult. And this is, in general, this is called radio frequency, RF. So RF, microwave, millimeter wave. So this is the common term. But you should be careful when you are either listening or interacting that in which sense. Sometimes the whole part except this optical part starting from terahertz to this whole band is called radio frequency because it is for radio or wireless. Radio is the synonymous term of wireless. এসো তুমি বেল দাও তোমাকে চাবি দিয়ে দেবে এই যে কেউ এসছে না কেউ জয়েন করলো
হ্যাঁ স্যার না স্যার মানে অ্যাপ্লিকেশন করেছি জয়েন করতে চাইছি
না জয়েন করতে চাইছি কিন্তু আমি দেখতে পাচ্ছি না জয়েন করে গেছে কি হ্যাঁ করে গেছে নিজে নিজেই করেছি জয়েন So now hopefully you get this abbreviation, low frequency, medium frequency, and the terahertz. So these are our signals. These are our waves. So depending on these waves, we need to choose our communication medium. So let's go through some historical aspects. This is the first and initial concept of transmission of radio signals. We should not call radio signals, sorry, electrical signals. This is the picture from 1844. And unfortunately, this service has been withdrawn just few years back. This is called telegraph service. So communication started with telegraphy. Then we came to telephony. So telephony is still valid. So this generation can see telephony both in wired and wireless form. But unfortunately, there is no telegraph. So these two lines, two wires, these two are the basic transmission medium or transmission line for electrical signals. It is of the beginning of last century, middle of last century. ছোট ছোট ভালো বলি ছোটটা টেনে দে এটা ছোট হ্যাঁ তোমরা কখনো have you ever seen this type of network?
No,
এই
sir.
যে স্ট্রিট ক্রসিং এ এই ধরনের নেটওয়ার্ক was very common in small cities, large cities because of telephone wires. Individual houses, so it is being distributed to all houses, all offices, so all for telephone communication. It is not really for telephony, telegraphy, it is telephony. So those are basically two wires, two parallel wires. Now I am seeing you some overseas line communication. It is from 1866. That is the gradual development. 4 cables to America. From which countries it is? এটা কি বুঝতে পারছো?
Ireland.
Ireland.
This is Atlantic. This is Atlantic, and this is the eastern coast of New York land or something like that. Is probably that part of eastern part of US, and this is Ireland. এই হচ্ছে দুটো ছবি. You just look at cabling process. এইভাবে they used to cross the Atlantic and they used to lay the cable. They used to lay across Atlantic, and this is the nature of the cable. This is one picture of the nature of the cable. So all made of wires. So all thick wires are there. So this is one cable. It is called multi-strand cable. একটা মোটা কেবল করলে কিন্তু flexibility থাকবে না. So hopefully you know the technology. When you use the wires in your wiring purpose, sometimes it is single and sometimes it is multi-strand, and multi-strand is more flexible. So to make it more flexible, less harmful, and in that case, if only one part is damaged, it won't affect. The other parts are fine. So when you used to use across the sea, so there is the possibility of getting damaged the different parts. So that is the communication medium for electrical signal across two countries or two cities, the different types of communication. This is telegraph line. Telegraph line is to follow railway track. all pairs of lines for multiple telegraph lines are being used for telegraph services. This is the clean picture of telegraph lines. It is, you see, the pair of lines. What is the purpose of transmission line? Transmission line's purpose. Can you tell the purpose of transmission line or purpose of one or two examples? Transmission lines means electrical set of lines or wires. Simply like that. Purpose kiki. Do you have to purpose bolo দেখি শুনি? Are you on?
Yes, sir.
বলো দু একটা।
Sir, for
Transmission of
communication as
microwave.
তার, আরে বাবা, তার দিয়ে করা, তার লাগানো জিনিস বাড়িতে কি কি আছে, বাড়িতে অফিসে কোথায় গিয়ে লাগে একটু বলো না কেন? তাহলে মিটে যাবে।
sir, landline telephones.
Landline telephone, good. That is one transmission line or electrical signal. Then
স্যার ব্রডব্যান্ড সিস্টেমে নেটওয়ার্ক কম্পিউটারের সাথে যেগুলো কানেক্টেড রয়েছে।
broadband network. দেখা যাবে, আমার কাছে কিছু ছবি আছে। This is a symbolic photograph. So nowadays you don't use, but it is, you are in the cities, but those who are far away from the cities, in many villages still they use this type of antenna, and there is the cable. The cable is coming to home and directly to either through a box or directly to the set. It is your sophisticated satellite-based television receiving system, and you need this cable, and this cable is coming to your room or to your set. It is for domestic purposes. Now you see for telecom service. Can you see this cable? All transmission
Yes, sir.
lines.
Yes, sir.
This cable is going to, cable look heavy, দেখো. This high power cable, this is going to transmitter. এই cable যাচ্ছে সব transmitter. So sorry, it is from transmitter, it is going to antennas. So this is the transmitting part, and this is going to this antennas. So what kind of communication it is? It is for your wireless. Sorry, it is cell phone. It is basically for your cell phone tower. So these are the basic typical examples using your domestic services or office commercial services. We come to this laboratory. If you come to laboratory, then you also see that we need this type of connections, right? This is called coaxial cable. The cables are basically of two types. Cables or wires are two types commonly used. And do you remember you have used this type of cable? The two leads like this. The long cable, which is a coil. This is called twin wire, TWIN, twin wire. This is called twin wire cable. So it is very similar to this old telegraphic cable. That is, there is one line, and in parallel there is another line. And this is the next generation cable. Initially it was not like that. Later on it was developed. It is called coaxial. Why? Because it has the one axis at the central and the other line on the surroundings. That is, the cross section is cylindrical. This is actually ground. Here anyone could be ground, anyone could be line. But here it is the ground and it is the line. So this is the main signal coming through this, and this is grounded. In between ground, so this is the metal sheet. So in between, sorry, metallic mesh. So in between this metallic mesh and the central conductor, there is some space. The space is not very healthy thing because it cannot maintain the shape. So it is filled by some dielectric. So this is the dielectric. The dielectric is actually serving the purpose of holding the central conductor. So there are two conductors. One is the outer conductor, one is the inner conductor. The outer conductor is one metallic mesh, and inner conductor is also one metallic wire. So this is square shell coupling. So these two are two very typical wires or cables we are using for our purposes. Anyone can read it out so that others can read out, others can listen to this. Read it. Oh, Indrila, you can read it.
Yes, sir.
Yeah.
Oliver Heaviside was a good student, but his parents could not keep him at school after he was 16. He was sent to work at a telegraph company. He took another job as a telegraph operator at the Danish Telegraph Company, laying a cable from Newcastle to Denmark. He soon became an electrician. Heaviside continued to study while working, and by the age of 22, he published an article in the prestigious philosophical magazine.
Wait.
Undertaking research from home, he helped develop transmission line theory, also known as the telegrapher's equation. He mathematically interpreted line attenuation and distortion. His equations helped implementing telegraph more efficiently.
So today we survive on the knowledge, understanding, technology. It was developed by a person, rather that time he was a student, who had, fortunately, who had no formal education. And more fortunately, he did not get chance to read any IITs or MITs. Fortunately not. Actually, this school dropout boy, when he was in this company, and particularly when he was working in this Danish company, he faced a problem. What was the problem? Problem is the cable was laid, but he found that there are several distortions in this line. But no one could solve the distortion. Then he tried to find out the reason. And he realized that without some insight, we cannot solve it. And what do you mean by insight? Insight means you need to model. You need to model this transmission line in terms of some known parameters so that you can manipulate those parameters and get it corrected. That is the purpose of any kind of modeling. Hopefully you know this modeling nowadays. The human system is modeled by electrical parameters. Are you familiar with this? That is called bioengineering. Suppose the circulatory system, that is the blood flow, or the nervous system, the equivalent model is done in electrical circuits. Then you can change different parameters and their equivalents, and by this way you can understand that which parameter in the body or human brain or human body or human system, it is malfunctioning, because you cannot directly control it without understanding. So this is the purpose of modeling. So he first tried to model simple two wires which are used to carry signal from a city to city, from a place to place, but no one used to know any kind of insight or any kind of malfunctioning. could not solve anything at that time. And you'll be surprised to know that this poor, that time he was only 22. How old you are now, you people? You are around probably 22, 23 or younger. Am I right?
Younger,
Younger,
Yes,
okay.
younger.
Younger, okay. Okay, you'll be reaching this age very soon, I'm sure. So he used to earn writing column. So most of his telegrapher's equations and derivations were published in one newspaper. And this newspaper for common people. That means these common people they were interested to know about science and physics. That's why the editors used to publish this in newspapers. And that's the beauty of the civilized country or one civilization. So I'm telling about the 1850s London. So how advanced the society was that time. So it was not like your Anandabajar. Only gossip or nonsense talking. So he modeled this transmission line in this format. Either the transmission line is two wires or the transmission line is just a cable. So only the transmission line alone cannot work. So we need at the end one load and other end there should be one source. Source, the inherent impedance or input impedance, or rather it is the source impedance, not input impedance, the source impedance that is modeled like this, and it is the load impedance ZL. Better we take this type of diagram for our use. Are you drawing this? Are you drawing this?
Yes, sir.
Okay.
Yes, sir. Sir, could you go to the previous slide? I was actually drawing. Yes, sir.
Follow.
Sir, could you go to the previous slide? I couldn't draw. I
You
couldn't
don't
complete
need
the
it.
drawing there.
Don't need it. You just take this one.
হ্যাঁ স্যার এই ড্রয়িংটা করছিলাম
You just take this one, right? So what I'm talking about
আচ্ছা
is
স্যার
absolutely I'm repeating what Oliver Heaviside told. It is absolutely from his model. Once you complete it, you let me know. This is the system. This is the whole system he modeled like this. Then Heaviside considered a segment of that one at a distance z. He considered one small segment at a distance z. He called it delta z. And he modeled delta z in a different way. One piece of electrical wire carrying electrical signal. How you can model it in terms of your known electrical parameters? What are your electrical parameters known to you? Resistance, capacitance, and inductance. Fortunate.
Yes, sir.
Over the last 2 or more than 2 centuries, the scientists are happy with these 3 parameters. Fortunately or unfortunately, we don't have any additional parameters for electrical engineers. Resistance, capacitance, inductance, okay? So based on that, he modeled this transmission line as an equivalent circuit. Just by concept that what kind of phenomena are taking place. So when there is a wire and there is electrical current, it may be time harmonic, maybe DC, whatever it be. So one manifestation of this circuit will be, it will generate heat. Why? What is the source of heat? যে কোনো একটা সার্কিটে যতক্ষণ যদি কোনো কারেন্ট থাকে তাহলে সার্কিটটা গরম হয়ে যায়, you know it. Question is
Yes,
why?
sir.
Why? Resistance. So resistance is one equivalent component of this part, Zn, delta Z. When there is current, there will be another phenomenon. You take this idea from Ampere. What's happening? When a conductor is carrying current,
So magnetic field.
magnetic field will be generated. That means a conductor, it will be surrounded with magnetic field, and this magnetic phenomenon of a circuit, it is represented by which component? Which circuit element?
Inductance.
Inductor.
Means when there is the magnetic field and a current element, then it will be, there will be some inductance will be involved. And when there is two current elements close by, is one element and one element, then automatically there is the possibility of having the effect of capacitance, right? Capacitance means
Yes, sir.
it is two metallic part connected to electrical system and separated by a distance. What is the actual significance of these three components? One indicates loss, and other two components, they indicate retentivity. Retentivity of magnetic field is represented by inductance, and retentivity of electrical field is considered in terms of capacitance. Electrical energy retained, conserved, magnetic energy conserved. So these two components, these two electrical circuit elements, they represent these two. And the other one is absolutely lossy. They represent loss. So this is the representation of a small circuit element or transmission line element, delta Z. Resistance represents loss, L represents inductance, C represents capacitance between these two lines, and there should be some leakage. Leakage means when there are two current carrying conductors, depending on the dielectric condition, there will be some leakage from here to here in the form of conductance. This is this thing for which in rainy season, most of us have experienced some electrical phenomenon when you touch your electrical switchboard or switch. হঠাৎ করে হাতে একটা ছোট্ট ঝনঝন করে উঠলো, আমরা বললাম ইলেকট্রিক্যাল শক খেলাম. It is actually some leakage current passes through our body because the isolation is not working perfectly because of huge moisture in the medium. তুমি যে আইসোলেটর দিয়েছো সেই আইসোলেটর কাজ করছে, তার প্যারালাল আইসোলেটরের জায়গায় ওই water content, water molecule, and this water molecule or moisture, it is a good conductor. So the medium surrounding some separator, there is another medium which is leaky. So are you happy with this equivalent circuit?
Yes, sir.
So this is our delta Z. So now we can define that R is per unit length, resistance per unit length. So when we multiply by delta Z, it is accounting for the loss across delta Z. Similarly, L is inductance per length, it is capacitance per length, it is conductance per length. So distributed parameter, that is per length quantity, and for delta Z we account for in terms of this. So after this equivalence, he applied some fundamental consideration and applied very fundamental circuit theory. What are circuit theory? তোমার জানা আছে বলো, সার্কিট কি অ্যাপ্লিকেশন আমরা করি? Ohm's law and
Yes, sir. Ohm's law, KVL, KCL.
Kirchhoff's law. So he applied Kirchhoff's law. আমি আর তোমরা, you are quite matured, you can find it out. আমি ঠিক লিখলাম কিনা দেখে নাও। Very fundamental Kirchhoff's law, because he had to use only the basics because he had no formal education. He was school dropout at 16. And interestingly, Kirchhoff's law, তোমরা বসে আছো এখন 1850s এ, না 1850s এ জন্ম, তার 16 বছর বা 20 বছর পরে উনি কাজ করছেন, তখন 1872। আর Kirchhoff's law জন্ম কত সালে তোমরা জানো? Most probably in 1840s, 1845. So by that time, Kirchhoff's law was quite matured and known. Well, so have you noted it down? Equation 1 and 2? Yes or no?
No, sir. Sir, please,
1 minute.
please give me some minutes.
Done? One is KVL, one is KCL.
Yes, sir.
What I'm going to tell, I'm not going to teach, I'm just going to convey the message to you, what happened that time and what is the reality. And it is absolutely very fundamental. I'm not going to tell anything very, very difficult. So you should consider delta Z infinitesimally small. Then only we can write the equation a little bit in a user-friendly way. From this previous equation, then you can write this equation in this form. And he actually did the same thing. I started from the very beginning that our signals are time harmonic signals. That means V and I, they are time harmonic. So this component is embedded. So I'm now taking the function as a function of z. That is, over the line, he had the issue with the distance, that when we are traveling through line, there was some distortion. So he considered that I need to find out as a function of z. Are you done? 5 and 6?
Yes, sir.
Done, sir.
Okay. Very interesting. R plus j omega L and G plus j omega C. We need to use it throughout our life henceforth. Okay. So obviously question comes that what should be our guideline? I tell you one thing very precisely, that the way I am telling and putting all before you, it is not exactly copied from any book or any published document. So if you are interested, you should seriously follow what I am telling. In addition, if you are interested, definitely you do. I would refer these two books. This is a classical book, Network Lines and Fields. All Indian versions are available. So as a student of electronics, at least you can see this. You need not purchase immediately. Elements of Electromagnetics is a very rich book, and if you can, I would suggest to have your own copy. I will cover many things from these Elements of Electromagnetics. And I would suggest, if you can, if you get, you should have one copy. And it will be helpful. Next is two books, very essential for all of you. Partly will be used in this semester, partly will be used in the next semester, and throughout your career, you may need these two books. One is Microwave Engineering by David Poser, the all Indian editions. DM Poser, Microwave Engineering. এই বইটা অবশ্যই পড়তে হবে, কিনবে কিনা it is up to you. And you need to consult, you need to read many times these books, the all Indian editions. It is famous by the name of Krauss. It is Krauss's antenna books. The whole world follows Krauss books. And David Poser, it is also now the international book for undergraduate students, undergraduate or postgraduate students. And this is the famous antenna book, but there is one more book by Balanis, but I won't suggest Balanis to be with you right now. So it is required to learn a few fundamental things. So from my side, reference books or textbook, whatever you say, I would recommend these 4 books. If you are interested, you can have these books with you. So we'll have our next class on next Monday. Do you have any question?
No, sir.
No, sir.
So today we have 27, so exclude me or myself, so it is 26. So can you have one snapshot? Shanudeep, you can have one snapshot and send it to me.
Okay, sir.
Okay, so okay, wait. Next is 8th, right? 8th Monday. Hello?
Yes, sir.
Yes.
8th Monday. 15th, I have one meeting almost whole day. 15th is Monday. So I need one alternative day. 18th could be. তোমরা নিজেরা দেখে নিয়ে আমাকে জানাবে যে নেক্সট অল্টারনেটিভ ডে কি পাওয়া যায়, ওকে?
Okay, sir.
Okay. So I'm closing. Good day.
Thank you, sir.